So let's talk about titration, the titration process. Let's first define some terminologies involved in the titration process. First, we have here the analyte. So if you hear the word analyte, class, this is referring actually to the sample, okay? To the sample. It's the substance wherein meron siyang content na ayun yung ina-identify natin. Is being identified or measured. So just like in your activity for the analyte, ano ba yung in-identify natin and measure natin last time? The first one is actually the sodium hydroxide, and then the second one is the hydrochloric acid. So both of the dalawang titration process, diba yun? So the first one again is sodium hydroxide. That is what we are measuring on the first titration that you did last time. And then the second one, hydrochloric acid. Analyte or sample, yun yung tawag natin doon. Now, titrimetry is the titration process mismo. It's called the titration process. It's the method, class, of determining the concentration of the solution. Okay, meron tayong solution na unknown yung concentration. So for us to know the concentration, we will do titration. Okay, yung analyte natin dyan, yung dinedetermine natin yung concentration. Again, the process is called titrimetry or titration. Now, we have the so-called volumetric titrimetry. Volumetric titrimetry siya kasi it involves the determination of the volume of the titrant. Yung titrant, ayun yung nasa burette. Okay? Yung nasa burette, diba? In the titration process that you did last week, ang in-identify natin doon, ang pinabasa ko sa inyo after the titration is yung volume na nagamit during the titration. So that is called, class, volumetric titration kasi it involves measuring the volume of a solution of known concentration. So after reacting with the analyte, you got the end point, and after the end point, there you measure the volume. Kasi meron din tayong tinatawag na gravimetric titrimetry, pero hindi natin ito ginawa, class, sa laboratory. Anong ginagawa sa gravimetric titrimetry? It's actually the same thing. It's just that the mass of the reagent is measured instead of the volume. So last time, it's the volume na in-identify natin. But for gravimetric titrimetry, instead of the volume used during the titration, it will be the mass of the reagent. Okay? And then lastly, for the types of titrimetry, we have the coulometric titrimetry. So si coulometric titrimetry involves the use of sophisticated na machine or apparatus or equipment, and this will, class, measure the electric current. So ang reagent, class, for coulometric titrimetry is a constant direct electrical current of known magnitude that will consume the analyte. So yung analyte natin kasi, ipapasok natin siya doon sa equipment na yon, and then i-measure natin kung gaano ka raming electric current ang nagamit to consume the analyte. So in here, the time required to complete the electrochemical reaction is measured. So gaano kabilis na-consume lahat yung analyte ng ating electrical current. That's coulometric titrimetry. Okay? So tatlo lang yon. Tatlo lang yon, ha. Volumetric, ito yung ginawa natin sa laboratory. I hope you can still remember anong ginawa ninyo. But after the endpoint, you measured the volume. Ito ang i-measure ang mass ng ating reagent. For coulometric titrimetry, ito yung gagamit na talaga ng certain equipment in the laboratory that uses electric current. And then, yung i-measure at the end is the time required to complete the reaction or to complete the consumption of the analyte by the electrical current. Okay, so tatlo lang yon. So ito yung process ngayon, the titration process in which you have a standard reagent added to a solution of analyte. Yung analyte class, most of the time, and dyan yan siya sa Erlenmeyer flask, except for cases na gagamit tayo ng primary standard. So, gagamit tayo ng standard reagent na ilalagay natin class sa burette. And then we will do the titration until it will be completed. Okay? So, ito yung actually ito yung picture ng titration setup, but you saw this in the laboratory. You have there the iron stand, the burette clamp kung saan natin ilalagay yung burette natin, and then the titrant. Please take note that the titrant is always placed here in the burette. So the titrant most of the time is the solution with known concentration. And then the analyte most of the time, it's not all of the time, it's most of the time, it's placed in the Erlenmeyer flask together with the indicator. So before class, you are going to do the titration, you have to read first the initial reading. So most of us had an initial reading of 0, except for the trial number 2, where I asked you to continue with the titration process na hindi na magdagdag ng titrant na maging 0 talaga. But again, you have to measure the initial reading first and then do the titration until there will be a change in color of the solution. That will be the endpoint. After the endpoint, you have to read, you have to have the final reading. Okay? And then for the volume of the titrant used in the reaction, ang ating formula lang dyan is final reading minus the initial reading. So, paano natin i-perform? Wait lang. I have to open this pala. Let's open YouTube and let's try to record. Sige. Again, for the titration process, ayun yung mga kailangan natin ha. The iron stand, the burette, syempre, the burette clamp, and your Erlenmeyer flask. So, sa burette, you will be placing your titrant there or your reagent. As long as, it's okay actually, it's not necessary nga naka-0 talaga yung initial reading. As long as you record class the initial reading. And then you will do the titration and then afterwards read the final reading and then just subtract to get the volume of the titrant used during the titration. So in the process class, if you forgot to add the indicator, wala ka talagang makukuha na change in color. So do not forget that also. Okay? So that is the titration process. Do you have questions about the titration process? Or meron kayong gustong i-clarify doon sa process na ginawa natin? Take note ha, depende siya sa sa indicator na ginamit. During our experiment, we used phenolphthalein. Therefore, the endpoint will be light pink. Pero pag ibang indicator kasi, ibang color din yun siya. Yung light pink, para lang yun siya sa phenolphthalein class. But take note that light pink should be light pink. If it is dark pink, it means you over-titrated. So you have to repeat the process. So sa akin, yung mga grupo under me, meron ako mga pinaulit kasi nag-over-titrate. Okay? Now we have the so-called back titration. We did not perform this in the laboratory, but when you say back titration class, it's doing the whole procedure except that ang tawag dyan, meron tayong dalawang titrant dito. Okay? Merong dalawang titrant. So, anong ibig sabihin nun? You have the analyte, the same thing pa rin. The analyte will be in the Erlenmeyer flask. You will add the indicator, but you will add the first titrant. Again, meron tayong dalawang standard solution or titrant dito. Mag-a-add ka muna ng standard solution in excess, doon directly sa analyte mo na nasa Erlenmeyer flask. And then after adding the first titrant, magpapalit ka ng titrant ngayon through the burette pa rin. So, ilalagay mo yung second titrant mo and then you will do the titration. So, anong pinagkaiba? Yung ginawa natin sa laboratory last time, ayun yung tinatawag na direct titration. Kasi isang titrant lang talaga yun, di ba? If you can remember, isang titrant lang yung dalawang titration process. Pero pag back titration, again, we have two titrants. That's the difference. Now, what are the reasons why we sometimes do back titration in the laboratory? Number one, when the rate of the reaction between the analyte and yung titrant natin is slow. So, may mga times kasi na almost maubos mo na yung 1 litro ng titrant mo, wala ka pa rin nakukuha na change in color. So that will be very slow. The reaction is not possible. So ang ginagawa, nagba-back titration. To aid the titration process, we will be using 2 titrants. Okay? And also, we do back titration if the standard solution lacks stability. So, hindi masyadong stable yung ating original na titrant. So, kaya may mga unexpected things tayo na mangyayari during the titration process. Pwedeng mag-slow down yung titration process. Kaya again, magba-back titration tayo. We will add 1 more titrant to aid the process. Now, kanina pa ako nagsasabing standard solution. Pag sinabing standard solution class, ito yung solution na gagamitin in the titration process in which the concentration is known. Okay? So, kaya ang tawag sa kanya, pwede din siyang tawaging standard titrant. So, titrant class na alam natin yung kanyang concentration. Now, you have observed this one, the use of standard solution doon sa experiment na last natin nag-titrate, yung sa hydrochloric acid. So, di ba ang ginamit natin na titrant for hydrochloric acid is the sodium hydroxide. And as you can see, sabi ko sa mga groups under me, na you cannot compute for the normality of the HCl without first computing the normality of the sodium hydroxide. So, si sodium hydroxide there is a standard titrant. Its concentration is actually known kasi by doing the previous experiment and computing for its normality, ayun, alam mo na yung normality ni sodium hydroxide before using that in the hydrochloric acid titration. So again, ang tawag doon, standard solution. Sa sodium hydroxide kasi na experiment, wala tayong standard solution doon kasi ang ginamit natin primary standard, in which I will also explain what primary standard is later. Okay? Now, before that, we have the so-called equivalence point. Okay? Pag sinabing equivalence point, it's just a theoretical point. Theoretical, we cannot see this during the actual experiment, but theoretically, it's the point wherein equivalent amount of our analyte and our sample have already reacted. So, equivalent na yung amount ni sample and ni titrant yung nag-react. That is the so-called equivalence point. It's a theoretical point because, as you can see, we cannot observe that in the actual experimentation. Okay? What we can observe in the actual experimentation is the endpoint. Okay? Endpoint yung tawag natin. Yung nakita nyo na nag-change na in color, like from colorless to light pink, that's the so-called endpoint. Ito yung makikita in an actual experiment, and this is associated with the use of indicators. You can physically you can physically observe the change in color. But the equivalence point, hindi natin ito nakikita. But nevertheless, class kasi, we assume that during the endpoint, ayun na rin yung equivalence point. Na kapag nag-change na siya in color, most likely there will be equal amount of titrant and analyte yung nag-react. Okay? Now, yung indicators, these are solutions class. Yes, Darlene, are you raising your hand? You have questions? Gusto kang itanong? Napindot lang? Napindot lang. Ako. Okay, gusto yung pangutana. Anyway, again, indicators class are solutions in the laboratory used in titration for us to see the endpoint. Okay? Yung mga indicators natin, marami sa laboratory, acid-base indicators. Kasi we use them during the titration process between an acid and a base. So just like our experiment, the potassium hydrogen thalate is an acid, and then yung titrant na ginamit natin is si sodium hydroxide, which is a base. Therefore, yung ginamit natin na indicator is an acid-base indicator, that is the phenolphthalein. Now, itong mga acid-base indicators, they have distinct colors depending on the environment. If they are placed in an acidic environment, iba yung color nila. Pag sa basic environment, iba din yung color. Kaya kapag there is a reaction between an acid and a base during the titration process, you will really see a change in color, a sudden change in color of the solution that is due to the indicator. Okay? So, ito yung mga examples class ng indicators natin. Sample ito ha, marami kasi sila. Sa experiment natin, ang ginamit natin, phenolphthalein. Okay? Phenolphthalein. Now, in acidic environment kasi, phenolphthalein is colorless. That is why, when we added the phenolphthalein in the potassium hydrogen thalate, the solution is colorless. Walang nangyari. Kasi ayun talaga yung color na phenolphthalein pag acidic ang environment. But for a basic environment, it is red. Red kung very acidic ha, pero kung slightly basic lang naman siya, ayun yung light pink or faint pink na tinatawag. But aside from phenolphthalein, aside from phenolphthalein class, there are still other indicators that we can use. Ito yung mga examples, masyado silang marami. And if you're going to ask me, ma'am, do we need to familiarize this one? Yes, you need to be familiar with the names of these indicators and also their colors depending on the environment that they are added. But one thing is to help you class be familiar with their colors, take note kung anong color yung kasama sa pangalan nila, ayun yung color nila sa base. And then automatic the partner will be yellow. Okay? Meron lang tayong some exceptions. Okay? Again, anong tandaan ninyo? For you to be familiar with the colors of the indicators, kung ano yung pangalan nila, ano yung color na nasa pangalan nila, ayun yung color nila sa basic environment, and automatic their partner will be yellow sa acidic environment. Now, ano yung exceptions? Number 1, itong mga methyl. Yung may mga pangalan na methyl, may methyl sa pangalan nila, baliktad kasi sila. Yung yellow class, based color nila yon. Okay? Just like this one. Okay? Pero yung acid color nila, hindi siya nakapattern doon sa pangalan nila. Just like this one, methyl yellow. Yellow pa rin yung base niya, pero ang acid is red. Si methyl orange, again, since this is methyl yellow, yung base environment, pero hindi orange yung sa acidic medium high, it's pink. Yung only na nagsunod dyan is si methyl red. So the rest dyan, malachite green, bromophenol blue, bromocrystal green. This one is green class, kindly change this. And then we have bromocrystal purple, bromothymol blue, and phenol red. Nakasunod yan doon sa ating rule na kung ano yung pangalan nila, ayun yung pangalan nila sa base, and then automatic their partner is yellow. Okay? Now, aside from that, may exemptions pa tayo dito, may additionals. Crystal exemptions, hindi to sa kasali. Kasali ito sa rules natin. So, red is still red here for crystal red. Again, automatic partner niya yellow, and that is also true for thymol blue. Itong dalawa kasama ito sa exceptions. Okay? So, wala din naman silang color sa pangalan nila. Phenolphthalein and thymolphthalein. So, take note, ang magkapareho sa kanila sa mga phthalate natin, colorless sila sa acidic environment. Phenolphthalein is red, thymolphthalein is blue for the basic environment, respectively. Okay? Questions about our indicators? Again, you have to be familiar sa kanila. Okay? Sure na? Okay, so the rules for the use of indicator, usually we use 3 drops of indicator na i-add doon sa ating Erlenmeyer flask during the titration unless otherwise directed. If the procedure states na you just need 2 drops, then you just add 2 drops. Pero nevertheless, if it is not stated kung gaano karami na indicator, usually it's 3 drops. Now we have class like rules in the use of our indicator. Usually, if we titrate a strong acid with a strong base, we may use MO is methyl orange, MR is methyl red, and PHP is phenolphthalein. So just like in our experiment in the laboratory, we used HCl, and then we have the sodium hydroxide. Okay, HCl is considered a strong acid. Sodium hydroxide is also a strong base. That is why we use class phenolphthalein. Okay, phenolphthalein yon. Now, yung isa experiment natin, we use the KHP, the potassium acid phthalate, and then we have the sodium hydroxide. So, potassium acid or potassium hydrogen phthalate is a weak acid. And sodium hydroxide is a strong base. That is why we also use phenolphthalein there. Okay? So ito yung mga pwede nating sundin if we do not know what indicator should we use during the titration process. Yung sa strong acid and strong base, aside from phenolphthalein, we may use methyl orange and methyl red. But if we are going to titrate strong acid with a weak base, we are going to use the methyl red. Again, take note, strong acid and then weak base na titration, methyl red yung gagamitin na indicator. However, if weak acid yung isa and then weak base yung another one na substance, plus we still have no indicator for this, and we have never titrated weak acid and weak base. Hindi sila kasi magkakaroon ng sharp na endpoint. So we have to make sure actually na if our sample is a weak acid, we have to use a strong base in order for us to obtain or to achieve a sharp endpoint. Walang available indicator for a weak acid and a weak base. Okay, so how do we know if it is a strong acid or a strong base? Most likely, class, the strong acids and the strong bases are inorganic acids and bases, meaning they don't have carbons in their structure, just like our example, hydrochloric acid and sodium hydroxide for the base. Okay, now our weak acids and weak bases, your weak acids and weak bases natin, most of them are organic. Okay, so they have carbons in their structure, just like our potassium acid phthalate. I think last time nag-draw ako ng structure ni potassium acid phthalate. Okay, meron siyang carbon. Okay, Ayan. So, yan yung ating rules in the use of our indicators. And then, we have the so-called primary standard. Ang tandaan niyo sa primary standard class, it's a solid substance. Again, it's a solid substance used during titration. And one example of this is the potassium hydrogen phthalate. Where's my pen? I cannot. Ayan. Ito yun yun. Oops. Wait. Ayan. Our example for a primary standard is potassium hydrogen phthalate. So this one is solid, right? I believe you weigh this one first. Naka-crystals ito. Solid substance used during titration. Since our sample class is sodium hydroxide, it's a liquid one. Nabaliktad kasi sila, si KHP instead yung nasa Erlenmeyer flask. And then our supposedly analyte has become the titrant actually during the titration process. Okay? Siya yung analyte pero siya yung naging titrant kasi siya yung nilagay sa urine. And then, ang ginamit kasi during the process is a primary standard. It's a solid substance na ginagamit natin as a reference material sa mga volumetric and mass titrimetric methods natin. But take note that for you to consider a substance as primary standard, meron siyang mga requirements na kailangan ma-fulfill. Number one is it has to have high purity and it should be stable atmospherically. And then, kailangan walang tubig glass. So, wala siyang hydrate water sa crystals niya. Walang water para hindi magkaroon ng changes sa concentration. Kasi pag meron siyang water, magbabago ang concentration nun. Makaka-add kasi sa amount of solvent yung water na nasa primary standard. And it should be hindi mahal, hindi expensive. And kung i-dissolve natin siya, since the primary standards are solid, kung i-dissolve natin siya, like for example sa water, kailangan soluble siya. And then it should have reasonably large molar mass so that the relative error associated with weighing the standard is minimized. So just like our potassium hydrogen phthalate, I believe it has really a large molar mass. If I remember it correctly, it's 204 grams per mole. Ito yung mga requirements for a substance to be considered a primary standard and can be used during the titration process. Okay? So how about the secondary standard? Ang kaibahan nila ng primary standard, si secondary standard is a liquid. Okay? So i-differentiate natin yung experiment number 11 ninyo na preparation and standardization of NaOH. Ito naman, preparation and standardization of NaCl. Yung analyte natin doon, supposedly NaOH yun. Okay? Ito, HCl. Pero nagkaiba sila. Kasi during the titration process, si experiment number 11 gumamit ng primary standard, solid na substance. Pero, sa experiment number 12, ang ginamit doon plus secondary standard, and that is the sodium hydroxide. So, si secondary standard is a liquid in which yung kanyang concentration is known para magamit siya in the titration. So, yun yung pinagkaiba ng experiment number 11 and experiment number 12. So, naging primary standard ito. Ito yung nasa Erlenmeyer. Ito yung nasa Buret. Okay? Buret. Okay? Dito, ito talaga yung usual na titration process na si analyte nasa Erlenmeyer and si titrant, si NaOH class nasa, yung titrant nasa Buret. Okay? Secondary standard yung tawag dyan sa liquid substance with known concentration used during the titration process. Okay? So ano naman yung mga requirements required for a standard solution or for a secondary standard. So number one, it has to be stable para ma-determine talaga yung concentration kahit isang beses ka lang mag-titrate. Ayun na, ma-establish mo na agad yung concentration niya. And at the same time, it should react rapidly yung doon sa analyte natin. Okay? So, hindi ka mag-a-add ng maraming amount talaga ng solution before mo makuha yung endpoint. So again, number one, dapat stable si standard or si secondary standard. And number two, kailangan mag-react siya agad with the analyte. Okay? And then, kailangan meron tayong satisfactory endpoint. So, pag sinabing pink, makukuha mo talaga yung pink na endpoint after the titration process. Okay? And then, undergo a selective reaction with the analyte that can be described by a balanced equation. So, kapag gumawa tayo ng chemical equation for its reaction with the analyte, makukuha natin agad. Okay? So, yun yung mga ating mga requirements for our secondary standards. Now, next meeting class, we will be doing the problem solving for the titration process, which is applicable also sa inyong laboratory na worksheet. So, babalikan natin class yung normality and molarity. Hindi pa kayo tapos with molarity and the normality na kahit na-discuss natin ito sa Chem101, balikan lang natin. Okay, we will be discussing direct method and standardization. Nakita niyo yung standardization sa worksheet ninyo, nakalagay doon, preparation and standardization. Kasi ang first part of your laboratory activity is preparation of your sample or your analyte, and then the second part is standardization. Plus, standardization means determining the concentration of your prepared solution through titration. Okay? Yan yung i-compute natin next meeting. For the meantime, it's 10:27. Before we'll end, do you have questions or clarifications? We will have our quiz next meeting before we will continue with our discussion.